All right, let's continue our discussion on the room library. So now that we have created the journal entry entity and the journal entry DAO, the next thing is to complete the complete building the database. So we are here. So database, as we saw, is a layer that handles the low-level SQL stuff for you, and your higher levels then essentially only deal with a Java or well, Kotlin code, and it helps keep it clean. It helps simplify maintenance and testing in the upper layers. Okay. So room database must be an abstract class that extends the room database class. Okay. And in most cases, you'll only need just one instance of it throughout the application. So here is the code. So public abstract class, journal room database, and extends room database, and you provide a single abstract method for getting the journal entry DAO. Okay. And then, of course, a lot of annotations here as well. So let's take a look at them. The app database annotation basically tells the system that this class should be used as a database class, and the entities attribute here specifies the tables to be created in the database. So here we have only one, but still you can see it's a sort of an array of classes. Okay, so you will get one table created from the journal entry entity class that we saw earlier. Version is the version for the database schema in a sense. So if you change the schema in future, you should increment the version number here. And there are strategies to handle conflicts and such things, but we won't go into the details of that right now because we are dealing with a very simple, straightforward app in the first place right now. Okay. All right. The export schema attribute is also related to the same thing. Um, it's false, indicating we do not want to keep history of several schema versions. Again, not really meaningful for our simple app right now, but yeah, for a more complex app with sensitive data, you may want to keep it. The next annotation here is type converters. Um, so the thing is with the entities, built-in types like the primitives and string, uh, the so room library basically knows how to translate that to appropriate SQL fields, but it does not know what to do with with the other types. For example, the UUID that we have used, which comes from Java, but I mean it's one of the libraries of Java, but room library doesn't know what exactly to do with that. And you can imagine, there can be several such um, classes, any custom that is a user-made class you may later use in your in your entities, in your schema of things. It won't know how to translate it, right? So you can provide type converters using another annotated class, which we'll see on the next slide. And there we tell the room library how to translate, in this case, UUID, for example, to and from a string. Okay. Um, Last thing here is this abstract function, abstract method. Again, this is something you don't have to implement. You just have to specify a public abstract method that returns the appropriate DAO. If it has the proper signature, its room library is going to implement it for you. So uh, you don't see any of the boilerplate code. It's all done under the hood for you, and you have very clean, very concise code in your app's code and your code repo like this. Okay, so next take a look at the type converters. Yeah, so here is a class. Again, it's a very regular Java class. You're not really extending anything, but you are annotating the methods with the @type converter. So you have this one, taking a string, returning a UUID. So we call it to UUID, and the string should not be null. Um, and it simply returns UUID dot from string. Okay, so UUID has a way of converting itself to a string. We are just using that. We are wrapping it around this and annotating it with type converter. Similarly, converting a UID to a string happens by a call to dot to string. Okay, and similar annotations here. So I probably could have simply used an int or a long in this particular example, but this is something to look at and learn for future cases. Okay, so now we are done with the entire lowermost layer. We have done the entry, the DAO, and the database. Now let's look at the journal repository. So as we saw earlier, a repository uh, is going to be used to abstract the access of the upper layer, that is the view model, to one or more concrete databases underneath. Um, Again, it could be local or web-based. The layer above view model need not know where exactly the database is. That information is abstracted through the journal repository, and that is the main contribution or the important aspect of the repository in this structure. Okay. Once again, it is not a part of the architecture component, but this is highly recommended. You could have your view model directly talk to the DAO, just like the repository does, as you'll see in a second. But it is recommended you don't do that. You have a repository layer, which, as I said, could then choose. I mean, you could implement another repository, and you could basically um, move your local database to cloud or something like that, and nothing upward, nothing in the upper layers has to be changed. That is the point. That is the advantage here. Um, and since it makes sense for repository to have only one instance, we are going to create a singleton pattern, another important object-oriented pattern here to access it. Okay. All right, yeah, so here we are. Um, so again, it's just a regular Java class, public class journal repository, and we have a constant for the database name, um, and a field for the DAO. And in the constructor, it takes the context. Um, this context, as the activity is a subclass of context. So we'll somehow need to pass that down here, and we'll figure out how. Okay, or something else, by the way. So there is the application itself, not just the activity, is a context. We need the context, and I guess why? Okay, so mainly the answer is, the sandbox model for protecting the data in Android, and um, letting only certain things accessible can be done using context. Okay, so unless you have a proper context, you cannot access that part um, of the file structure. So that is the basic high level idea here, right? Let's see what's happening. So you create um, a database variable. You call room.database builder, pass it the application context, um, and the database class which you want to use to create the database. And the third parameter is the database name, which is coming from here. And then you call build on that. So note we are passing it the application context and not an activity context, okay? Because the database is for the whole application. It's not an activity specific thing. You may have different tables that are relevant to different activities, but the database itself is for the whole for the whole app, right? So we are getting the application context out of it and building it using that. Okay, and then you just get the journal entry DAO from that. Remember where this method was? Let's go back a couple slides here. That method was declared over here. We never really defined it. We let the room library do that, but that is the method we are calling, database object and dot journal entry DAO. Okay, So now you can see how things are getting connected. All right. Yeah, so here we build a database, and here we get the associated DAO. You might have noticed this constructor is private. So question is, who is going to call that? Let's see. We are doing this for the singleton pattern, to be honest. That's why it is private. Okay. So for the singleton pattern, we'll first create an instance, a static instance of the repository. Okay. So this is static. It's at a class level. It's not going to be an actual. It's not a field. It's a static member. And then we develop an init method, um, which takes a context and checks if the static instance is null. If it is, then it creates a new um, journal repository instance by calling the constructor. Okay, so this ensures that we'll only have one valid instance of the repository at any given time. The constructor was private and init is public. So this is the one you can call from anywhere, but then the init ensures that there is only one instance initialized. So that's the point here. And then you can have a get instance, which returns the instance that should have been initialized from anywhere. Okay, so you initialize it once, and you call the get instance, and then operate on it from any place, any number of time. So it also checks if it is null. If the instance is null, it throws an illegal state exception. Okay? So this is how you can implement a singleton pattern in Java in general, and here, of course, in Android. Now let's see where we are going to call these methods, the init and get instance, so we can actually handle those, right? So to do that, to use the proper application context, we are going to extend the application class now. We have seen subclassing the activity all the time. Similarly, there is an application class, and there are lifecycle methods like onCreate in that application. And you can, of course, extend it to add to override and add any other code that you want. So what we are doing here is subclassing the application, and its onCreate method, we are overriding that. So the onCreate method is called when the application is launched. Why we want to do it here and not in an activity? Because the application is more likely to outlive any activity instance, right? We know that activities get destroyed when you rotate the device, and so on, but the application can live longer. So we are going to instantiate uh, uh, the repository when the application itself is launched. Of course, applications can crash, and in that case, you'll again create the repository if and when the onCreate is called. That is when it's launched again. So that's what is happening here. We are calling the init method here, and creating the repository, or rather initializing the repository just at this one time. So we won't be calling init from an activity or a view model or any other place. Okay. Now a question, we always said we should not pass the activity instance to the view model or to the backend, because it's bad practice. There may be memory leak. So what do you think about passing this as the application this here? Think about it, and we'll discuss it in class, or on the forum. Okay, this is all we'll do with the application class. We are overriding the onCreate method to initialize the repository, but that is not enough. You also have to go and make a small change in the manifest file. You basically have to specify the name of the class that you're using as the application. So this is similar to what we saw with the activity classes. Okay, so that way it's the same. All right. We'll pause here and we'll talk about the Android thread model in the next video. Thank you.